Welcome dear students. Let's continue with the last video on increasing and decreasing function. Okay, so far what you have done is we have tried to prove whether the given function is increasing or decreasing in a given interval. But this time in today's class we'll be finding the interval in which the function is either increasing or decreasing. Okay, so for example, the first question for the day says find the intervals in which the following functions are strictly increasing or strictly decreasing. Okay, so here what thing that we need is, for strictly increasing the condition is f dash of x is greater than 0. This condition is required, and for strictly decreasing the condition is f dash of x is less than 0. So you must know these two conditions. Okay, now since you have got f dash out here, so we need to differentiate the function. Okay, so let's differentiate this. So when you differentiate this, you get f dash of x is gonna be equals to 2x minus 4, isn't it? And it's always better that you factorize the remaining stuff. Okay, so when you factorize this, you get this much. Okay, so you know that f is strictly increasing if f dash of x is greater than 0, right? So f dash of x is 2 into x minus 4. So this is greater than 0, so it means x minus 4 is greater than 0, and it means that x is greater than 4. Okay, so suppose if I draw a real line, okay, if I draw a real line, and if 4 is somewhere out here, okay, so greater than 4 means it starts from here. Okay, I'm excluding the point, so that's why there's a circle, and start from here and it goes this way. So can I call this interval to be open interval 4 to infinity? Yes. So therefore this is your x greater than 4, no? So therefore what we say is f is strictly increasing in the interval 4 to infinity open interval. Okay, so this is how we need to do. Okay, in the same way, okay, so we know that f is strictly decreasing. F is strictly decreasing if f dash of x is less than 0. So this time f dash of x means we have 2 into x minus 4 is less than 0. So it means that x minus 4 is less than 0, and it means that x is less than 4. So x is less than 4 means it starts with this way and it goes this way till minus infinity. Okay, so therefore we say that f is strictly decreasing on the interval minus infinity to 4, and remember this is also open interval. You cannot put close because there is no equal to sign here. So this is how we need to do this kind of sum. You may pause the video and note down the solution, and if you want to draw the diagram, that also can be done. Okay, so pause the video and note down the solution. Let's move to next questions. So next question is also similar thing. So f dash of x is gonna be 2x plus 2. So if you factorize this becomes 2 into x plus 1. Okay, so f is strictly increasing if f dash of x is greater than 0. So in place of f dash of x we have 2 into x plus 1 greater than 0. So this is x plus 1 greater than 0. So from here you get x is greater than minus 1. Okay, now similarly let me do the other part also. F is strictly decreasing if f dash of x is less than 0. So it means that 2 into x plus 1 is less than 0. That is x plus 1 is less than 0, or x is less than minus 1. Okay, so again let me draw a real line. Okay, let me draw a real line in order to explain you well. So this is -1, let's say. Okay, so whenever x is greater than -1, so greater than -1 means going this way. Okay, that is from -1 to infinity. If my value lies in this interval, okay, then the function is strictly increasing. So that's why we say that therefore f is strictly increasing if, not if, in the interval open interval -1 to infinity. Okay, and now if x is less than -1, if x lies somewhere out here, that is from -infinity to -1, closed in open interval again, then function is strictly decreasing. So therefore f is strictly decreasing if, not if again, in the interval, let me directly write the interval, that is -infinity to -1 open interval. I hope this is clear to you. Pause the video and note down the solution. We have yet another question. So this time question is going to be a bit challenging now. Okay, so f dash of x, so f dash of x is gonna be, so you get 2x cube becomes 6x square minus 6x minus 36. Okay, so something is common out here, isn't it? 6 is common. So if you have 6 common, then you get x square minus x minus 6. So as I told you, you need to factorize this. Okay, so for factorizing this, use breaking the middle term, x square minus something x minus 6. Okay, so the numbers I need to write here is 3 minus 2 x square, so this becomes, okay, so open the bracket, so x square minus 3x plus 2x minus 6. Okay, and not x square, yeah, so it's 6 here. Okay, so it's 6. Okay, so 6 into, now you see what is common here, x is common, so x minus 3, and plus here 2 is common, so you get x minus 3. Okay, so you have bring x minus 3 outside, you get 6 x minus 3, and what is left here, x plus 2, right? So your f dash of x is turning out to be this much. Okay, now see, in earlier cases we got linear factor. Linear factor means this kind of factor. Okay, so here also we got linear factor, but here we have got, see, it's a quadratic factor. So quadratic is changed into linear. Okay, now in such case what you need to do is you need to find the value for x at which f dash of x is going to be 0. Okay, and you have to show the work in a real line. Okay, so what we will do is we will find the value, okay, at which f dash of x is 0, and such value, the value at which f dash of x is 0, is called critical point. We call it critical point. So let's find critical points. Okay, so to find critical points, so what you need to have is f dash of x must be equals to 0. Okay, so it means that f dash of x is 6 into x minus 3 into x plus 2 equals to 0. So from here what you get is x will be 3 and other value will be minus 2. Okay, now what am I going to do is I'll draw a real line. Okay, so let me draw a real line. So we have a real line, and on this real line I'll plot these 2 points. So if minus 2 is somewhere out here, okay, and your 3 is going to be somewhere out here. Okay, now you have got 3 regions. If you see you have got 3 regions. This is your region number 1, region number 2, and this is your region number 3. Okay, now what am I going to do is see here very carefully. Choose any point from here. We can take -3 from region 1. Take any point, so you can take -3 because -3 lies out here. Now put the value of x to be -3 in this. Okay, so if you put -3, what do you get out here? It becomes -3 is -6, and this becomes -1, isn't it? So -6 and -1, so negative. When you multiply, you get positive. So that means f dash of x is positive in region number 1. I hope this is clear to you. So here what is happening, f dash of x is positive. Now let's check what happens in region number 2. Okay, now in region number 2, what happens is, okay, so take any value. For example, we can take 0. So if you take 0, then this becomes -3, this becomes 2, so it's gonna be negative into positive is negative. So f dash of x is gonna be negative this time. Okay, now choose any value from region 3. For example, you can take 5. So x equals to 5, put that, so you get 2, 7, so both are positive, so positive into positive is positive. So that time your f dash of x is going to be greater than 0, positive. Okay, so therefore after drawing this diagram, then we are done. Okay, so what we can say is, for the function to be strictly increasing, okay, for the function to be strictly increasing, f dash of x must be greater than 0, isn't it? So for, okay, let's write this way. So from the diagram, from the figure above, it is clear that f is increasing, right? Increasing means increasing in the region 1 and 2, no, 1 and 3, right? Okay, now let's see what are these intervals. Let me name this also. So it starts with -infinity and ends with 2. Remember, you cannot put 2 because if you, you cannot put -2 because when you put -2, it becomes 0. F dash of x becomes 0. So that's why this interval becomes -infinity to -2 open interval. Now similarly, this is going to be -2 to 3 open interval, and this is going to be 3, infinity. Okay, so therefore what we can say is, therefore f is increasing, not only increasing, it's strictly increasing, is strictly increasing on, so on which interval? In this -infinity -2, okay, but it is increasing in this interval also, so you need to take union out here, union 3 infinity. Is this clear? So this is the required interval. Okay, now, and f is strictly decreasing on the remaining interval, that is where f dash of x is negative, and that is -2 to 3 open interval. Okay, so we have got our answers out here. So this is how we need to do. Pause the video and note down the solution. Right, so we have yet another question, so I will leave this question for you to do by yourself. Okay, let me move to another question. Yes, let's see this question now. Okay, so given is f x equals to this one and x is not equals to 0. So let's see how much do we get f dash of x. Okay, so before we do that, so what we can do this here is fx is equal to, I can write this as 4x plus 1 by x, isn't it? That will be better. Okay, now find f dash of x now. F dash of x will be 4 minus 1 by x square, isn't it? And what you can do is you can factorize also, right? So for factorizing, what you can do here is, okay, so what we can do here is you can apply a square minus b square formula, right? Okay, so we can apply a square minus b square formula, and you get 2 minus 1 by x into 2 plus 1 by x. So that's what we are going to get. Okay, now again this is a quadratic, and in case of quadratic we'll find the critical point. Okay, so to find critical point, you must have f dash of x equals to 0. Okay, that is, you have 2 minus 1 by x into 2 plus 1 by x is equals to 0, isn't it? So you get, see here carefully, so you get either 2 minus 1 by x equals to 0 or 2 plus 1 by x equals to 0. Okay, so from here what you get is x is equals to half, okay, or x is equals to minus half. Okay, so these are the two critical points. Now again, what am I going to do is I'll draw a real line. Okay, I'll draw a real line and I'll plot minus half, okay, and I'll plot half. So again there are three regions being set. Okay, so there are three regions being set. Okay, so what we'll do is we'll do the same thing out here. So let me call this as region 1, call this as region 2, and call this as region number 3. Okay, now let's see what's happening out here. So take any value which is less than minus 1. For example, you can take 1. Okay, so in region 1, if you take 1, then let's see what do we get out here. So it is 1, so 2 minus 1 is 1, so this is also going to be 2 plus 1, 3. So positive into positive, it's going to be positive, so f dash of x is going to be positive. Now in between these two you can take any value, for example 0. So if it takes 0, no, you cannot take 0, x is not equals to 0, so you cannot take 0 also. So here 0 is also excluded, remember. Okay, so 0 is there, so obviously minus half and half also needs to be excluded, so 0 is not there. Okay, so apart from 0, for example, take 1 by 4. Okay, so when you take 1 by 4, so what happens is this becomes 2 minus, this becomes 4, so 2 minus 4 is minus 2, so this becomes 2 plus 4, which is 6. Minus 2 into 6, that is positive into negative is negative. So here what happens is, in this interval, what happens is f dash of x is gonna be negative. Similarly check, you will find that here f dash of x will be positive. Is that clear? Okay, so again it's the same case, no? So therefore we say that, therefore from the figure above, f is strictly increasing on the interval. Okay, so the first interval is, so let me write the interval also. So this is from minus infinity, so minus infinity minus half, this is from half to infinity. Okay, now I'll talk about this later. So in this two interval the function is strictly increasing, right? So that's why I need to take their union. So we have minus infinity to minus half union with half comma infinity. Okay, and f is strictly decreasing on which interval? On region 2, right? Now region 2 is what? It is minus half comma half. But remember, this includes 0 also. Minus, if you count from minus half to half, from here to here, it includes 0 also. So I need to remove that 0. So for removing 0, I need to subtract this way. Okay, I need to subtract 0. So since this is a set, So from set you cannot subtract a number. From set you have to subtract a set only. So that's why I have put 0 within this bracket. I hope this is clear to you. So you may pause the video and note down your solution. So let's move to next question. So next question, in the next question we have to again so this is x to the power 4, so your power is increasing now. Okay, so this time you have f dash of x. So f dash of x will be equals to, so it's going to be 1 by 4, so x to the power 4 becomes 4x cube, plus you have 2 by 3 into x cube becomes 3x squared, minus we have 5 by 2 into x squared becomes 2x, minus we have 6. Okay, so these things gets cancelled, so you get x cube plus, okay, so you get 2x squared minus 5x minus 6. Okay, so now we need to factorize this if it's possible. Okay, so for factorizing this, what should I do? You can make use of remainder and factor theorem if you remember from your class 10. So what we do is we will roughly take any value. Okay, take any value for x and try to get 0. Okay, so this work you have to do in rough work. Okay, so this is my rough work. So first start with 1. So this becomes 1 cube plus 2 into 1 square minus 5 into 1 minus 6. So let's see how much is this. 1 cube is 1 plus 2 minus 5 minus 6. Is this equals to 0? No, this is not equals to 0. Similarly take minus 1. So when you take minus 1, so when you take minus 1, then let's see what do we get. So this becomes minus 1, this is plus 2, this is plus, right? And we get this much. Now check, is this equal to 0? Yes. So x equals to minus 1 is giving me, x equals to minus 1 is giving me what? It is giving me the value. Okay, it is giving me what? It is giving me the value of this to be equals to 0. Okay, so what we do here is bring this out here, so it becomes x plus 1. So x plus 1 is one of the factor here. Okay, so divide this quantity by x plus 1. So that work you need to do in rough, let me tell you. So x plus 1, let's divide x cube plus 2x square minus 5x minus 6 in the rough. Okay, in the rough part. So here you have x cube, so x square into this is x cube plus x square, subtract, so you get 2x square minus x square is x square minus 5x. See, I'm assuming that you know this. Okay, so that's why I'm doing it very quickly. So plus x, so you get x square plus x. Okay, so subtract, you get minus 6x, so bring this minus out here, so you get minus 6, so minus 6x minus 6. Okay, so when you divide this by this, you get this much. Or in other words, if I say, and if you multiply these two, you will get this one. Is that clear? So that's why here what am I writing is, so this part you have to do in rough, as I said. Okay, so let me write it here, that this is x plus 1 into x square plus x minus 6. Okay, I hope this is clear to you. Okay, now can I factorize this other factor, this factor? So x plus 1. Okay, so when you when you do the middle term breaking, so what you are going to get here is x plus 3 into x minus 2. When you do the factorization of this, you are going to get this much. Now to find critical point, you must have f dash of x equals to 0, right? So f dash of x is x plus 1 into x plus 3 into x minus 2 equals to 0. So from here we get x equals to minus 1, minus 3 and 2. So these are the 3 critical points. So remember, in earlier questions we had only 2 critical points, but this time we have got 3 critical points. Okay, so kindly look at this very carefully. Okay, so let me do it here only. So we have got a line, real line. Let me okay, and let me plot these 3 points out here. So -3 will be somewhere out here, let's say. Okay, and this is your -1, let's say, and let's say this is your 2. Okay, so this time you have got 3 regions. Okay, so what am I going to do is, let me take one number from each region. Okay, so for example, you have got -4 in the first region, so put -4. So you get a -4 plus 1 is -3, so -2. So negative, negative, you get positive, so -4. Again you get negative here. So negative into negative is positive, right? So no, negative. So here you get f dash of x will be negative. Okay, similarly, if you find here, let's see what do we get here. Choose any value, let's say -2. So if you take -2, this becomes negative. This also becomes negative, but this becomes positive. So negative into negative is positive. Similarly, you will get f dash of x will be negative here, and here f dash of x will be positive. Okay, so therefore, now this time, therefore, from the figure, f is strictly increasing on. So increasing means we have to take these two interval. Okay, remember these critical points has to be excluded, so that's why it becomes -3 to -1 open interval, union we have got open interval 2 to infinity. So in this interval, function is going to be strictly increasing, and f is strictly decreasing on, so on the interval. So this is the first interval, which is -infinity to -3, union there is one more interval, that is from -1 to 2. Okay, so this is how we need to do this kind of sum. Okay, pause the video and note down the solution. Okay, so we will have 2 more questions of similar type, but this time your function is going to be a bit different. Okay, so given is fx is equals to x square e to the power -x. Okay, find f dash of x. So this is gonna be, so this is in the form of u into v. So keep e to the power -x as it is, differentiate x square, you get 2x, plus now keep x square as it is, and differentiate e to the power -x, it becomes -e to the power -x. Okay, so you see what is common out here, e to the power -x is common, x is also common. Okay, x is also common, so what you get here is 2 minus, so here you have x, that's what you are going to have. Okay, now see, we have got see, if we to find critical point, let's do that. Okay, so to find critical point, what we can do is f dash of x must be equals to 0. We have f dash of x is e to the power -x, x into 2 minus x equals to 0. Now e to the power x can never be 0. Okay, I have told you this many number of times. Put any value for x, e to the power -x will never be 0. So from here what do you get is x minus x into 2 minus x equals to 0. So it means that x is equals to 0, okay, and x is equals to 2. So these are the 2 critical points out here. Okay, and remember, we just need to find the interval in which the function is increasing. It's increasing, not strictly increasing. Okay, so for that, let me draw a real line. Okay, and we have got 2 points, 0 and 2. Okay, right. So here let me check the sign of f dash of x. Okay, so what happens to f dash of x? Let's check. So f dash of x. Okay, so in this interval, take any value, let's say -1. Okay, so as I said, this doesn't matter, so we'll look at only this. So -1, and this is gonna be 2 minus minus 1 is going to be 3. So negative into positive is negative. So it's going to be less than 0. So in this interval, take 1. Okay, so take 1. So if you take 1, then it becomes 1. So 2 minus 1 is 1. So 1 into 1, that is positive into positive is positive. Similarly, take any point, let's say 3. So if you take 3, it's going to be negative. You know why? Because you get minus 1 and you get 3 out here. So it's going to be negative. Now since function is talking about increasing, function increases out here. And this interval is going to be this time, can I include in 0 and 2? Definitely, isn't it? Because question is saying increasing. So if question is saying increasing, then we must have equal to or greater than or equal to 0, isn't it? So the function f is increasing if f dash of x is not only greater but also equal to 0. So since the function is 0 in this point and in this point, so that's why therefore f is increasing on this time closed interval. Okay, closed interval from where to where? 0 to 2. Is that clear? So you may pause the video and note down your solution. Let's have a look at the last question. So the last question says find the intervals in which the function, okay, so again strictly increasing and decreasing. So given is fx equals to 2 log x minus 2 basis e, okay, minus x square plus 4x minus 5. Now let's differentiate this. So when you differentiate, you get f dash of x is equals to 2 by, now it becomes x minus 2 in the denominator minus this is 2x plus 4. Okay, right. So, let me simplify this a bit. X minus 2. So you see here we have got 2 common, so you get x minus 2. Okay, simplify this. So when you simplify this, if you write 1 out here, LCM is x minus 2. Okay, so this is gonna be 2 minus x minus 2 whole square, isn't it? Okay, so now in order to find the critical point, see here carefully, in order to find critical point, so what we do here is, so we will just factorize the numerator, okay, because denominator we just have a linear factor, okay, and from the denominator it is clear that x cannot be equals to 2. X cannot be equals to 2. Okay, so to find critical point, so we must have f dash of x equals to 0. Now you know f dash of x is 2 minus 2 into x minus 2 whole square divided by x minus 2. Okay, so this is equal to 0. So bring this out here, you get, okay, so if you take 2 also common, that will be better. Okay, so right, so let me do it here only. So take 2 common, so 2 by x minus 2. Okay, so it becomes 1 minus x minus 2 whole square. Okay, so let me write it this much here. Okay, so this becomes 2 by x minus 2 into 1 minus x minus 2 whole square, okay, is equal to 0. Now bring this here, so you get 1 minus x minus 2 whole square equals to 0. Okay, now if you want to open the bracket and form a quadratic equation and solve, that is also fine, or else you can solve from here also. Let me show you how. Okay, so you get from here x minus 2 whole square is equals to 1. So find x minus 2, it will be either 1 or it will be x minus 2 equals to minus 1. Simple, because when you take square root you get plus minus, no? Okay, so from here x will be 3 and from here x will be how much? 1, isn't it? So from real line, okay, now we will draw a real line and plot these two numbers 1 and 3. So again they are talking about strictly increasing and strictly decreasing. Now choose any point out here, and remember 2 is also excluded. Okay, so this 2 is excluded, so 2 is excluded out here. Instead of drawing this, what you can do is you have to make a blank out here, no? So make a blank, so 2 is excluded, because in the denominator we cannot have 0. Okay, now choose any point from here, take 0. Okay, so if you take 0, so what happens, let's see. Okay, so this is always gonna be positive, so 1 minus 0 is 1. Okay, so in the denominator what do we get, 0 minus 2 is minus 2. So positive, in the numerator we have positive, and in the denominator we have negative, so obviously you get negative. Overall thing becomes negative. F dash of x is negative out here. Okay, similarly let's take at this point, take any point, for example 4. So 4 minus 2 is positive, so this is positive. What about this, 1 minus 4 square is 16, so 1 minus 16 is minus 15, so negative. So obviously again this time also you have f dash of x is negative. Obviously in this interval you are going to have f dash of x is greater than 0. Okay, so from the figure, therefore from the figure, f is strictly increasing this time, strictly increasing on, so increasing on this interval apart from 2, so it is open interval again, so 1 2 3. Okay, open interval 1 comma 3 minus 2. Okay, and f is strictly decreasing on which interval, this interval, which is minus infinity to 1 union with this interval, which is 3 to infinity. Okay, I hope the sums that we did today were easy and understandable. Okay, so with this we close the chapter on increasing and decreasing functions. All right, thank you very much.